We said that the difference between a sequence and a series is a sequence was just a pattern of numbers, whereas a series was adding up those numbers. So let's look at a series. That is the sum of all the terms in a particular sequence. So I guess we could just simply write it as term 1 plus term 2 plus term 3 all the way up to term n. Shorthand notation for that is to simply say Sn instead of Tn. S meaning the sum rather than individual term. And using sigma notation, you'll recall from statistics, capital sigma means the sum of. So sigma notation, we say the sum of the general term, term k, but going from k equals, well, usually 1, but it doesn't have to be, and then all the way up to whatever the last term happens to be. So if we see something like this, and it's in sigma notation, it's telling us that the general term is 2n plus 3, and we want to add up all the terms starting when n equals 1 to n equals 5. So at this stage, all we do is substitute into our general term for 1, so we get 2 plus 3, then 2, 4 plus 3, and so on, going up to n equals 5, 10 plus 3, add them together, 45. We know that the sum to 10 terms is 29, and the sum to 11 terms is 37. Could we then work out the 11th term? And the answer is, well, yes, we could, even though we don't know what the general term is and we don't know what the pattern is, because what must be true is that the difference between the sum of 11 terms and the sum of 10 terms must be the 11th term, because to get the sum of 11 terms, we had to add the 11th term onto the sum of 10 terms. So I'll subtract 29 from 37, and we now know that the 11th term is 8. They've given us a general formula, but not for an individual term, a general formula for the sum to n terms. So can we then work out what the general term is? Well, we use the same idea as the last example. Term n must be the difference of the sum to n terms, take away the sum to n minus 1 terms, because to go from the sum to n minus 1 to the sum to n, I must have added on the nth term. So sum to n, they've given us that formula, 5n squared minus 2, subtract, now we substitute n minus 1 wherever we see n, so 5 lots of n minus 1 squared minus 2. And so expand out, group like terms, and we get 10n minus 5. So we've come up with a general term for term n. Well, let's look at arithmetic series in particular. So the sum to n terms, that would be the first term, a, plus the second term, a plus d, plus the third term, a plus 2d, and so on, and so on, and so on. And eventually we'll get to the last term, and let's just call the last term L. Now that means the second last term must have been L minus D, and the second last term must have been L minus 2D. Well, that's so good, I'm going to write it again, but backwards. So L plus L minus D plus L minus 2D, and then we keep going, and now the last one I'm writing down is A. Well, why on earth do that? Because let's look at it like simultaneous equations. And if you line up the columns there, you'll notice there's a whole heap of D minus D, 2D minus 2D, and so on and so on. So all of those differences will disappear. So when I add them, I'll get A plus L, and then the next two will give me A plus L. The differences cancel out. Then I get A plus L. The 2Ds cancel out. Every one of those columns either cancels out or gives us A plus L. But the question is, how many of these A plus L's do I have? Well, there's one of those A plus L's for every term in the series. And we said we were summing up n terms. So we must have ended up with n lots of A plus L. Divide both sides by 2, and I now have a formula. It does require me to know the last term, though. So there's my formula, n on 2, A plus L, if we know L. Well, if we don't know L, I do know that the general term is a plus n minus 1d. So let's sub that in for L. That would then give me the sum to n. So I've got n on 2, a plus n minus 1d. Wow, let's tidy that. And we come up with sum of n is n on 2, 2a plus n minus 1d. So we don't actually have to know what the last term is. Now be careful with this formula. It's very easy to make a mistake and just go a plus n minus 1d because we're so used to that with the general term. But remember, this was the first term plus the general term. So we end up with 2a. All right, so let's look at some examples. The first term is 3. The sixth term is 96. What is the sum of these 6 terms? Well, I know the last term, so I'll use that n on 2 a plus L formula. And it really is just a substitution now. So n is 6, a is 3, L is 96, 297 for our answer. Find the sum of the first 100 even numbers. And let's just imagine for a second that I haven't got a clue what that last even number is. I just can't work it out. The first term's 2, the common difference is 2, and the number of terms is 100. So I can use the other formula, n on 2, 2a plus n minus 1d. Substitute in all of that information, so 100 on 2, 4 plus 99 times 2, we end up with 10,100. The sum of the first 10 numbers is 100. The first 5 numbers is 25. So from that information, we should be able to work out the first term, the common difference, and the general term as well. All right, so the sum to 10 terms is 100. So that means n on 2, 2a plus n minus 1d, in this case 10 on 2, 2a plus 9d is 100. I'll just play around with that one a bit. We get 2a plus 9d is 20. We also know the sum to 5 is 25. So 5 on 2, 2a plus 4d, n on 2, 2a plus n minus 1d is 25. Play around with that. A plus 2d is 5. 2 equations, 2 pronumerals. It should be possible now with simultaneous equations to work it out. So I've got 2a plus 9d is 20. I'll multiply the second equation by 2. 2a plus 4d is 10. 5 differences is 10. Therefore, the common difference is 2. Substitute back in. A is 1. So I've got the first term. I've got the common difference. We now need to work out the general term. Well, general term, a plus n minus 1d. 1 plus n minus 1 times 2. 2n minus 1. So we have all 3 things. So I'll just complete this question by writing down all the information in one line that they asked me to find. A is 1, D is 2, and the general term is 2n minus 1. Sigma notation. So the general term is 3n minus 6. We're going to start when n equals 1, and the last term is going to be 10. So let me extract that information. N equals 1 would be the first term. So 3 minus 6 is negative 3. I've got the first term. The last term is when n equals 10. So 3 times 10, 30 minus 6 is 24. I got the last term. We've got 10 terms all up. I'll use the a plus L formula. So n on 2, a plus L. Subbing in, we get 105. The thing to watch out for with these sigma questions, if it doesn't have n equals 1 as the first term, then make sure you calculate the number of terms carefully. For instance, in this one, say the first term we were using was, in fact, n equals 3. Don't make the mistake of just substituting n equals 10 because that's the last number. We don't have all the terms. We're going from 3 to 10. How many terms will we have going from 3 to 10? Well, it's actually 8, not 7. I know some of you said 7 because 10 minus 3 is 7, but it's inclusive. So it's 10 minus 3 is 7, but plus 1, 8 terms. Watch out for that one. Okay, so 1E and 1F and 1F.